In this session, we're going to look at the three main building blocks that allow us to repeat tasks in a program. It doesn't matter what language you're programming in, you'll always find the ability or a way to execute these three types of loops. The first is a while loop, and what that means is that it's going to stay looping while a certain condition is true. So we're going to test a condition. If it's true, we're going to do whatever actions are inside the loop. We'll come back, we'll test the condition again. If it's still true, we'll execute again, and we'll continue doing that until that condition becomes false. The next kind of loop is an until loop, and this one means we're going to go into our loop, we're going to do all the actions, and then we're going to test at the end. If that condition is true, then we'll fall out of the loop. If not, we'll go back and repeat the loop again, and we'll repeat that loop until that condition becomes true. The last type of loop is one that we use if we want to do something a fixed number of times, and it's generally a for loop. It doesn't matter which of the three types of loops we're going to use, they all have the same basic for elements. The first thing that has to be done is that we have to initialize whatever variable we're going to be looping on. So it might be a count, it might be something that's checking the status of something, it could be a different condition. Whatever it is, we have to initialize that first. The second thing you will always see in a loop is a test of that condition. So if we're testing a count, we might be looking for it to reach a limit of 10. If we're looking for a flag to be set to indicate something that is now an acceptable input, we'd be looking for that to be true. But we're going to have some kind of a test. The third thing that we're always going to see is a block of actions or instructions that we're going to execute while we're in the loop. The fourth thing that we're going to see is a modification of that loop variable. If that variable never changes, we're never going to get out of the loop. So somewhere inside that loop, there has to be an instruction that changes it. The first type of loop we're going to look at is the while loop. And we can see here in the pseudocode that we have all four parts. So we have an initialization of the loop variable, we have a test, we have the actions, and we have a modification. We can see the same thing over here in our flowchart. So we come through, we initialize our loop variable, we test our condition. If it's true, we go into the loop, we perform the actions, we modify the counter, and then we come back and we test again. If it's still true, we come in, we do the same actions again, and we continue doing that until we come back and this test variable has been modified so that it no longer tests true. In that case, we follow this path down, exit the loop, and continue on with the rest of the code. If after we've initialized that variable, the test condition is not true, we're going to follow this outside path, not do anything at all inside the loop, and come down and continue with the rest of the code. So there is a possibility with a while loop that the code we have inside here, the actions, never get executed. This type of test is called a pretest. And the reason it's called that is because it tests before the actions. So here's the test, here are the actions. If we come down and look at the code itself, we can see the initialization of our loop variable. So our variable is called OK, and we're setting it to false. Then we're testing it. So while OK is equal to false, we're going to test it to see whether it's inside a range between minimum and maximum, and if it is, we're going to set our looping variable to true. We come down to the end of the loop, we come back up to the beginning again, do the test one more time. In this case, OK is equal to true, and so it's going to fail the test, skip to the end of the loop, and continue on. If, on the other hand, we come in, it's initialized to false, we come in, while OK is equal to false, so it comes into the loop, we test the value. If it's outside the range, we print an error message, we come back, OK is still false, we do a test, we set our flag. In this case, we're never going to get out of the loop because inside here we have nothing to change value. So what we would need to add in order to make this a valid loop is some kind of an opportunity for maybe the user to enter a value, and then we would check its limits. You'll notice with the loop, just like we had with our decision blocks, there is one entrance point and one exit point. The second looping structure we're going to look at is a repeat until structure, and it's going to repeat until a condition becomes true. We see the same four phases. There's the initialization, there are the actions, there's the modification, and there's the test. If we look at our flow chart, we can see the initialization. There are actions first thing inside the loop. There's the possible modification of the loop variable. If it has changed such that the condition is true, we would fall out and continue on. If, on the other hand, we come through, we do the actions, we modify the variable, and it's not true yet, it's going to loop back, perform the actions again, another modification, and it's going to repeat that until that condition becomes true, in which case it would fall out. You'll notice once again we have one path into the loop, one path out of the loop. If we look at our C code, we have a similar code to what we saw on the last screen, where we're initializing our variable to false. We're testing a value that we haven't input in here, so again that would be a better idea to have the user input a value here. We check it to make sure it's in range. If it is, we set our flag to true. If it's not, we'll print an error message. Our test says, while it's not OK. So if we say not OK, that means the same as OK is equal to false. So if OK hasn't been changed to true, we're going to stay in the loop. If it has been changed to true, it's going to fail this test and continue on. This particular type, because the test is at the end, is called a post-test. So we had a pre-test with a while loop and a post-test with a do-while loop. The third type of loop we have is a for loop, and that's when we want to do things a certain number of times. We have the exact same four things. We have an initialization, a test here, which is we're counting from a start to a finish point, the tasks, and the modification of the counting variable or looping variable. If we look at our flow chart, we have our initialization to the starting count. We check to see if we've reached the last count. If we haven't, we do the actions, we modify the counter, come back, test again. Are we at the last count yet? Nope, we'll come in, do it again, and we'll repeat that until we get to the last count, in which case we come out and out to the end of the program. If we look at our other options, we come in. If our start count happens to equal our last count, we're going to come this way the first time and not do anything inside the loop. As before, one path in, one path out. If we look at the C code, it's a very simple format. For is our keyword, and in here we have our initialization of a counter to 0. It's very common to use I, J, and K as your variable for counting loops. So here we're initializing, here's our test, and it tests just like a while loop. So this says we're starting with I equal to 0, and then we're saying while I is less than last count, do this action. So we're going to increment a value called answer by I each time, and we're going to print the current count is equal to whatever answer happens to be right now. The last thing in the brackets is our modification to the loop variable. So that's going to happen after the actions in here get done. So the initialize happens first, then we do the test, then we do the actions, we do the modification, and back to the test again. If we still haven't met the condition of the test, we do the actions, the increment, and continue until we fall through. So we have three types of loop. A while, which is a pretest. We have our initialization, our test at the beginning, the code that we're going to execute while the condition is true. Our repeat until loop, which is a post-test, which means it tests at the end. So we have our initialization first, we have the actions that are going to be done inside the loop, a modification of the looping variable, and the test of that looping variable at the end. And then we have a for loop for doing things a fixed number of times. We're going to use a for loop from an initialized value. While it meets the condition, we will do these actions, incrementing our looping variable at the end of each loop.